Good morning, grade 8 with you, Mr. Samir Awad, and now we are with lesson 2, chapter 2, scientific literacy. And here we have three axes to talk about the beginning, why is scientific literacy important for us? And number two is how do you analyze scientific claims? And number three will be with part two, how do you research scientific questions? So let's launch. First of all, scientific literacy. Scientific literacy means understanding scientific terms, principles well enough to ask questions, evaluate information, and to make decisions. For example, when you are going to talk about something like solar eclipse or something like that with the people, you have to get your information directly from the books and from trustable areas in order to talk about that. And when the people ask you, you will start to know if this question is getting to be logic or not. And that will be also get you to evaluate the information you're getting, is it relevant and reliable or not. To understand the many issues you encounter, you need scientific literacy. By having scientific literacy, you will be able to identify good sources of scientific information, evaluate them for accuracy, and apply knowledge to questions or problems in your life so that you will use that as a backbone for you and helpful. Secondly, will be evidence and opinion. And there is a difference between evidence and opinion. In opinion will be your point of view, but on the other side, evidence had to get a proof. Yeah, if you get a proof for opinion, it will turn into evidence. So evaluate scientific information. You must first distinguish between evidence and opinion. In science, evidence may or may not support a scientific claim. So if someone is getting to say that I'm going to now examine the people and see if there someone is going to cough in your house, you will say, yeah, someone said it's a coronavirus. He got corona, he catch corona. No, that's his opinion. We don't have evidence that this person is getting corona or all the symptoms of coronavirus or COVID-19 are getting to be on this person. But when we start to test him and we get it positive, so the evidence will be here supporting the scientific claim we said. But on the other side, if we test him and it was negative, the evidence here will not support the scientific claim. So if we say by the end, we can conclude that evidence includes observations and the conclusions that have been repeated and trustable to be repeated. Opinion is an idea that may be formed from evidence but has not been confirmed by evidence. So you have to get a proof for it in order to turn it into evidence. Here we'll see geese are too lazy here. But on the opposite, you have to know that geese spend up to 12 hours they eating grass and roots. That means that we have evidence for that here. But on the other side here, that was an opinion. How do you analyze scientific things? And scientific literacy gives you the tools to analyze scientific claims. Scientific reasoning gives you the process. So you have two ways. You have to get the tools and to get the process, like how to eat and what the tool you are going to eat with. That's scientific literacy and scientific reasoning are like the two hands of handling the thing. So you can use scientific reasoning to analyze scientific claims by looking for bias and errors in research, evaluating data, and identifying faulty reasoning. So it's talking about most to be trusting everything about its bias and how much is going to get faulty reasoning. That's by scientific reasoning. The literacy will help me to see if the claim is going to be true or not. So research here needs to find out if people in the town have good computer skills. So the researcher advertised online for participants to take the test. He offers a free thumb drive as a payment. So 20 people take the test. Everyone gets a perfect score. So if we get here, the researcher concludes that the town's residents, all of the town residents have excellent computer skills. And that's wouldn't be good for us. So if we get back, guys, what is important here for the source of error in research, that first of all, there were 20 people that applies to the test, and that's not good representative number for my test all over the town. So not enough residents were tested to be able to draw a conclusion all over, to generalize it. Two, and that's which is perfect, and that's the core of our here experimental bias. You get it? The only place to see the advertised was on computer. So we expect the people who see the advertising through computer to be good people to use the computer. So I cannot expect the people to be bad with using computer and get bad computer skills when they are getting the advertising from the computer. I have to spread it out in the streets to see if the people, all of the people, or mostly my sample will be getting to use a computer or not. And that was another mistake there. Here we have applied here, read the sample advertisement here, then use scientific reasoning to analyze its claims. Here we use improve your test scores, a scientifically proven new way to get better grades. Just look at our research results. Subject A studied for 30 minutes in front of the TV and didn't use our product, scored 72 points. Subject B studied for 3 hours with a tutor and used know-how, scored 90 points. That means 25% higher grades with know-how. And you can make the grade order know-how today. So this advertising is asking us to buy this product because it will help you to get more score, and that was in more time, will take more time from you to get more score. And that's, times 6 of your efforts you use it from TV only. But on the other side here, when you start to use the total itself, you get 90, which is 25% extra, but you exert more efforts for 2 hours and a half around. So that will be cost and benefit too. So first of all, interpret data. How many subjects were in the study? Here there was 2 subjects, A and B. Yeah. Evaluate scientific claims. Do the research results support the claim that using know-how helps people to get better grades? Explain and answer here. The sample is no. Only 2 people were in the study, and variables such as time, study environment, and support were not controlled. I didn't get the same things in order to make my study. I have to get the variables, the other variables to be controlled to be the same, and one variable, which is the independent, will be different, which is the TV and the tutor itself. Here also, while subject B score actually 25% higher than subject A score in calculate, that's exactly when you get that you will get, yes, it's 25% of 72 will be 18. And when I add 18 to 72, it will be 90. So I get 25% extra of this one. It was true with them. Thank you guys for listening. Wait for part 2 of scientific literacy. Was with you, Mr. Samir Awad. Be safe at home and good luck. Bye.